Okay, we are looking at the problem that is on the screen, and what we are trying to do is trying to find a solution to this problem where we actually start from the diode model itself. Okay, so let's assume that the diode is off. Let's start off by diode is off. You could have started with diode is on as well, but I'm going to deal with the diode is off case first, and then we'll do the diode is on. Okay, so let's say the diode is off. What do you mean by off? What we mean by off is the diode is in reverse bias, right? So let's draw the circuit then. If that is the case, this is how the circuit is going to be. You have this voltage source, you have this resistor, and then instead of a diode, you can substitute an open circuit, right? Because in the reverse bias, when the diode is off, there will be no current flowing through this circuit. And we make this 12 volts. We make this is Vn, this is R. Okay, now what is the current going to be through this circuit? Now you can see that there is an open circuit here, so there cannot be any current flowing through this because there is no finished sorry, there is no complete circuit, right? And so the current is zero. Okay, if the current is zero, what is the voltage across the diode? What is Vd, let's say? And you can easily see that, right? You can write the voltages by just putting the signs. Let's say we put plus minus, this is plus minus, and we go along around this circuit. So we get V in, and then the voltage drop across this resistance is going to be zero because the current is zero. Okay, because the current is zero, the voltage drop across this resistance is zero. And then we have V in minus Vd minus 12 equal to 0. So what we have is V in minus Vd minus 12 equal to 0, which implies Vd equal to V in minus 12. Okay, now we have assumed here that the diode is off. If the diode is off, what will be Vd? Vd is less than 0, right? And what is Vd? Vd is V in minus 12. Okay, so let's write that. So V in minus 12 is going to be what? It's going to be less than 0, which implies that V in is less than 12 volts, right? So the diode is off when V in is less than 12 volts. Okay, and at that time the current is 0 and Vd is equal to 0 as well because it's V in, or Vd is less than 0. Okay, and at that time the current is going to be 0. Okay, so let's do a similar step for when the diode is on. And let me just draw a line here so that we can separate out the problem, and let's try to draw the circuit again for the case when the diode is on. So in this case we have, this is V in, and you have this resistance here, you have the diode, and the diode is replaced by a short circuit, and then you have your 12 volts here plus, and that's 12, and that's R, right? And in this case now we can find out the current. So let's try to find out the current. What is the current going to be? So this is the current I, and we can see that we can see what's the voltage across the resistance. The voltage here is Vn, and the voltage here is 12. So what's the current? The current is given by I is equal to V in minus 12 over R. So that is what is going to be the current. And of course, uh, if V in was less than 12, we know that the diode is going to be off. So this is the case when the diode is on. So V in V in is going to be greater than 12, and therefore this current is going to be positive, which is exactly what you need for the diode, right? Because for the diode, the current needs to be positive. You can't have a negative current flowing through the diode. So we can say, so then we can say diode is off when V in is less than 12 volts. The diode is on when V in is, let's say, greater than 12 volts, and this is the current. And if that is the current, what is the voltage across the resistance? The voltage VR is I times R, which is equal to V in minus 12. Okay, so when V in is greater than 12, then the voltage across this resistance is going to be V in minus 12. And when V in is less than 12, the voltage across this resistance is going to be 0. Hope that makes sense.